You know, but really my number one thing is if the kids are having fun, they'll want to learn. So I'm trying to make lessons and for them that are fun, that are hands-on, and that are real. So, yeah. Yeah, my name is.
Thank you so much.
So my name is James Pike. I've been currently I'm working at Citizens of the World Middle School in Los Angeles, California. I've been teaching pretty much. I mean, I've been teaching my whole life. My mom's a teacher. My aunt's a teacher. My family has like we have doctors and teachers. So when I was young, I would go to class with my mom, and whenever I needed a job in college, I teach ESL. And then after college, I wanted to move to Japan, so I became a teacher again. And then after I came home, well, it was pretty much the only thing I've ever done. So I got my credential, and I wanted to make school fun and enjoyable for my students, and I kind of put a lot of effort into that. So yeah, Harry?
Yeah, James, I think your mother's and father's influence must be there on you to become a teacher, I think.
Oh yeah, my mom's an excellent teacher. In fact, she's still my substitute. So if ever I'm sick, my students go from Mr. Pike to Mrs. Pike. But I make them call her Miss Mom. Yeah, so it's kind of in the family bloodlines. We have teachers and doctors. So
yeah. So James, what time is it now over there? For our participants, could you please tell us the time of the day there?
Oh, it's 2 a.m.
Participants, you can see that it's almost 2 a.m. there in Los Angeles, but our guest teacher has made himself available for us. It's really great gesture. Thank you so much, James, for burning the midnight oil for us.
Oh, I like to stay up late at night, so it's fine. I enjoy this.
Okay,
and I gotta say, Harry, it's a real honor and pleasure that you've taken an interest in my work and what I've done in the classroom. I see you work with teachers, bring in to educators from around the world, and and I've met your class, and your students must love you. And frankly, Harry, you inspire me, and that's why I feel like I'm lucky I get a chance to show this to you guys.
Thank you so much for your kind words.
That is the greatest compliment for Harry, sir.
Yeah, thank you so much, James. So now I would like to request you to share your work. If you have any videos, please share it with our colleagues.
All right, no problem. So this kind of project I like to call, it's a project-based learning unit I like to call cardboard construction. And what we do is, well, I'll show, and the standards we are going after is finding the area, a perimeter surface area of, that's like the standards that we're hitting. So let me show you what kind of got the inspiration for this going.
Yes.
All right, so this is a young man who was a kid, and he built an arcade. His dad is an auto mechanic, and he built an arcade out of the cardboard boxes that that went to his dad's shop. So here we go. It's called Kane's Arcade. Ignore the
to us on glassesusa.com, then at the store.
Can you hear okay?
Yeah, we can.
You're not just paying for the
All right.
glasses.
When you're a lonely 9-year-old boy, an empty cardboard box can be a universe of possibility. And sometimes the real world takes notice, responding with simple human kindness. ABC's David Wright takes us to the garage where dreams are made.
It's a funhouse arcade made of cardboard boxes.
The first game I made.
9-year-old Kane Monroy built it in his dad's auto parts store at a junkyard in East LA.
Here we go.
Kane's Arcade is pretty intricate.
I missed.
There's basketball and soccer and a homemade claw machine.
I got tokens, passes, and prizes.
He used his own toys for prizes. Everything manual. The one thing Kane didn't have was customers. Kids at school didn't even believe he had an arcade. Then filmmaker Nirvan Malik walked in.
It's got to go into one of those hoops?
Yeah.
Looking for a car door handle. Instead, he found a movie.
And then when you score a point, he would crawl into the box and he pulls out these little tickets out of the side of the cardboard.
Like real arcade games, tickets come from the bottom.
And I was like, this kid's a genius.
He came up with a special surprise for Kane. He put out the word on the internet, and one Saturday, while Kane was getting pizza with Dad, hundreds of total strangers showed up. A throng of customers for Kane.
We had people coming from everywhere. I couldn't believe it.
Cameras rolling as Kane finally arrived.
Wow. What's going on over here?
He got out and he said, wow.
The movie posted online late Monday. Nearly 2 million people have watched it, contributing more than $100,000 to a college fund for Kane.
What did it make you feel like?
Proud that people know my arcade.
He's just psyched the movie
Looks too hard for me.
Not that hard.
means he'll soon have a lot more customers.
Awesome.
David Wright, ABC News,
I won a prize.
Los Angeles.
So I took that kind of idea of students building arcade games. Some of my students build buildings. They can build whatever they want. But as we go, we measure out our pieces and we find surface area of different kinds of things. So this next set of videos are from my class when they're actually kind of doing the math on it. So let me go back to my screen share. Am I still screen sharing?
Yeah.
All right, good. So right here, you see how she's got a card. She's doing the surface area, and she's finding how much wrapping paper she needs for her to cover her present.
Surface area, I added 80 plus 30.
So James, nothing is visible. I think we are unable to see your image.
Oh, my bad. Thank you for telling me.
Yeah.
Is this better?
Yeah, we can see.
She's made a present, and she had to find the volume of the box and the surface area for the wrapping paper.
Because so you would find the area of each side, which is length times width, and then added them all together to get 112. And then for the volume, I did height times length times width to get the volume of 80.
So we can't see.
Oh, were you able to see that?
Yeah, we are able to see.
No, sir.
Ma'am, are you not able to see?
Yes, sir. It is visible.
It is visible, sir. Yes, it is visible. Visible.
Visible.
It is visible.
All right, so yeah, this is how they would find surface area and volume by getting a box. And this is kind of how I start them off, with just boxes that they already have, measuring and finding the area and surface area of that. Then you take a rectangle and you cut it in half, and you get triangles. So let's go.
Hey guys, I like the surfaces basically, and we're gonna be like finding the surface area of this little house thing I built. It's kind of tiny, but still has a big surface area. And we're gonna be like looking at the planes on it. Here, all like the surfaces basically, and we're gonna be finding the area of each one, adding it up, and adding them up, and getting the total, which will be our surface area. So to get started, each rectangle here is 8. So we have one here, and one here. So 3 of them, 3 times 8 is 24. And then these little squares, those each have an area of 4 in square inches. So 2 of them will make 8 square inches. And then finally the trapezoids at the top. Each one of them has an area of 6. So that'll be 6, 12. Then each one of these triangles has an area of 3. So 3, 6, and 12 plus 6 is 18. So now that we have 32 and 18, we can add them together. And 32 plus 8 is 40, plus 10 is 50. So our surface area for this entire house will be, in the end, 50 square inches. I rounded to the nearest inch for a bunch of them. It was like 2 of those little lines on the ruler off, but tell me if I shouldn't do that. Bye.
So another thing I really like what he did is that to make his math easier is he rounded. And then he's actually using rounding in the next step. Like what's great about this kind of lessons, there's so many different kinds of ways that you can bring math into it. So if they want to be exact and do decimals, they can. If they want to round and make the math easier, they can see why they would want to use rounding. The parallelogram.
So today I might be explaining.
That's the definition of a parallelogram. Okay. It's been so.
So these are mine. I have no idea how to get this filter off. But this is my square. The base is 5 and the height is 4, and so it's 20 inches. My triangle is base is 5, height is 2.5, and the area is 12.5. And my parallelogram is the base is 3.5, the height is also 3.5, and the area of it is 12.5.
So, we cut up the car, we get a rectangle, we find the area of that, and then we cut it in half, and then they can kind of see that right away. Then I ask them, how do you find the area of a triangle? Well, when they cut the cardboard in half, the rectangle in half, they realize they have 2 triangles and they cut it in half. So then they say, oh, I just find the area of the base and the height, and then I divide it by 2. Once they kind of get good with just the shapes, I set them loose to make their own set of arcade games or houses or whatever else they want to make. It's then it gets really into their own ingenuity at that point. So that's kind of like the ins and outs of how I do it. It's a short presentation, but if you have any questions, if you'd like to discuss more, I would love that.
Yeah, definitely. So James, stop sharing so that I request my participants. Yeah. Thank you. So
one thing.
Yeah.
Go on.
James, go ahead.
Yeah, one thing I really like about this is it's really accessible for everyone because everyone could have cardboard and tape. That's pretty much all cardboard, tape, and markers and some measuring tape. Those are the materials you need, some scissors, and then you just go for it and have fun. Sometimes my students, I catch them playing they tell me they're playing their games for hours at home, or they're designing like buildings that they're in forts and finding out like how much area they need, so it would be how much cardboard that they used. So it kind of has real world applications as well.
So now I request our participants one by one, and you can go ahead and come up with your questions, please.
The expenses?
No, I request my participants to interact with you. Yeah. So Raka ma'am, go ahead.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63, 64, 65, 66, 67, 68, 69, 70, 71, 72, 73, 74, 75, 76, 77, 78, 79, 80, 81, 82, 83, 84, 85, 86, 87, 88, 89, 90, 91, 92, 93, 94, 95, 96, 97, 98, 99, 100, 101, 102, 103, 104, 105, 106, 107, 108, 109, 110, 111, 112, 113, 114, 115, 116, 117, 118,
Ma'am, you have muted your microphone. You have muted your microphone, ma'am. We can't hear you. No. Still not audible.
Me?
No, it's not the participant, actually. Participant. So it seems that we have a problem with Raka ma'am, and anybody else, please.
Sir, can I?
Yes, ma'am.
Hello, sir. Namaste, sir.
Namaste.
This is Mangarani. I am a secondary grade teacher. I am dealing with class 1 to 5. And in primary school children, they are thinking math is difficult subject. And they are very struggling to, some children are struggling to do abstract math concepts. So how do you plan to deal with this problem in your classroom, sir?
Well, it's kind of fun. And if you're doing something with the younger kids, I mean, maybe you're not doing area perimeter of parallelograms, but you're just doing measuring. How many centimeters long is this? So they build an arcade game that they want to play like a little basketball game, and they measure how tall it is, how long it is. And then you just kind of scale the goal down to just measurements of different sides of your game. But they'll be excited to build these things. They'll use their imagination, and then when you're just asking them for measurements, they'll realize as they're building, knowing the measurement will help them build it better.
Okay, sir. Thank you.
Thank you.
So any more questions from our participants, please?
Shall I, sir?
Yes, ma'am. Lakshmi.
Yeah. Hello, sir.
Hi.
Hello, sir. Namaste.
Namaste.
I'm Lakshmi, working as English assistant, and now I'm working in Diet College. That means Diploma in Elementary Education as a ELTC lecturer. So my question is, generally, most of the children are scared of two subjects that all of you know. One is English, because that is foreign language here, and next one is maths. And the government also show much concentration in developing these two subjects. Generally, we can overcome development of English language through communication skills, and by watching English movies, cartoons, etc. we can overcome. That is okay. But how can we overcome this scaredness among our children about this maths subject? And another question is, what about this constructivism? Is it okay to implement, or that means through constructivism, can we overcome this problem? This is my query.
To make a full overcome, I mean, I think you can do a lot to overcome the problem of making them scared of math. Because for them, if math is only on a test paper, it has no meaning outside the test. If they're building an arcade game that they've created, they've envisioned, they'll get excited for it, and then they'll have to play with the shapes, the geometry. They'll start to understand the geometry of how to put things together, because it will be meaning for them and fun, and they'll be building it with their own two hands. So I think you'll get a lot more engagement out of that. You'll still have some of the anxiety around kind of like math test, but that's what one of the advantages of project-based learning is that the kids get into their projects. One thing that we can do to tailor that is, like, we have to do a lot of word problems. You can make the word after they make the boxes, or during the making the boxes, you can use you could ask questions about the box. You know, like Lakshmi, what's a good Indian name? Raja wants to make a top to go on his cardboard box game. It is 20 centimeters long and 10 centimeters wide. What's the area of the box of the lid he's going to need to make on top of it? So you can kind of maybe word the problems around that way. Or how much space does he have inside to build his cricket game or his soccer game? Then you start thinking about how much space inside and start bringing in volume that way.
Right. So what about this constructivism? Do you follow this constructivism in your area?
I follow constructivism as much as I can, but you know, I got bosses who give me curriculums. So I have to listen to them as well. But I do a lot of constructivism with my projects, and I find them the most meaningful. And that's where we get the best discussions about math and just have fun conversations about it, is about what they're building. And it works, and you're able to get a high level engagement from a good chunk of the class. So I find it's working in my classroom, but I still have a curriculum to follow as well. If I had my own school, well, then yeah, we'll be doing a lot more constructivism. But normally I get a good constructive project about one a semester. I would like to do more, but I got to listen to my bosses.
Right. Thank you, sir. Thank you very much.
No, thank you.
Any more participants? Any more questions, please?
Sir, am I audible now?
Yes, ma'am. It's visible and audible also. Go ahead.
Thank you. Hello, good afternoon, James. This is good afternoon in our country, and maybe in our country it's early morning. Good morning. Hi, James.
Good morning.
Good morning. What is the way you are introducing? Before that, I'm saying I'm a math teacher. So my question is, what is the way introducing negative numbers?
Oh, one way to do negative numbers. What's the largest mountain in the world?
Pardon again?
For negative numbers, I mean, you could have games where you lose points, and then they can kind of design that into the play. But when discussing negative numbers to introduce the concepts, things like debt is a good way to do that. It teaches financial literacy. But I always like to start with the question, what's the largest mountain on Earth? No, so what would you say the largest mountain on Earth is? You would think it's Mount Everest, right?
Yeah.
Mount Everest is the tallest, but it's not the largest. The largest mountain on Earth is Mauna Kea. It's the large island of Hawaii. Most of that mountain is underwater. So we can start using the sea level, and then they can see that this mountain was built from the bottom of the ocean up to above the water. So this is the height, is the positive side, but then the whole thing is the negative. The underwater is the negative side, and if you put it together, then you can teach absolute value. But debt is another good way to do it because it's financial literacy. Because you know, if you're in debt $100, you need to make $101 before you have any money.
Okay. Okay, good. My another question is, are you giving homework to your students?
Not giving homework to my students.
Yeah.
I'll tell you, I give my son a ton of homework. Yes, I give homework to my students. Some of it is to catch up. Some of it is to get ahead. And I do think I'm not really big on homework, but I do think it has a place just so they know how to sit down and do work by themselves. But you'll find with a lot of the constructivist work, the cardboard box building, you build the box as your homework. You build your game as your homework. You come to school with the boxes, with the ideas, and then that's where you kind of measure it out and do the math there. So the homework is the fun part.
Oh, great.
That's one way you can get the homework in. I also do like them building it in the classroom because then I get to teach engineering, but in a straight math class, you might not have time for that.
Really great, sir. You are focusing on hands-on activities mostly for homework.
Yes, yes.
You're focusing on homework mostly?
No. Not like that, sir. Hands-on activities. Learning by doing.
Learning by
Yes, sir.
doing.
James, sir,
Doing.
actually, suppose the student is not interested in maths. How you motivate?
Well, what are they interested in?
Not interested in maths.
Oh, I know that, but I will start with what are they interested in? So, you know, find what they like and build everything is math. Everything can be measured. Everything can be timed. Everything can be sped up and slowed down. Everything can be grown. So, I mean, as a math teacher, I'm sure you can see math in anything if you want to look for it. So I kind of like do projects that I start with what they like. For instance, in this project, what kid doesn't like arcade games? What kid doesn't like games? You know, so you start with that and you build the math around that with the theme.
Okay, great.
That's fine, sir. But could you please suggest any ways to our maths teachers? Just as ma'am asked, na? So if you are in the place of ma'am, how can you overcome that scariness, that what I asked earlier?
So have them go home and measure the boxes, write the numbers on the boxes. They have measuring tape and measuring sticks at home, I presume, rulers. You know, so you kind of show them how to do the rulers, and all they have to do is just kind of mark it and write a number. And that's usually pretty easy. So then it does take the fear out. And then, oh, I measured this side and I measured that side. What happens if I put them together? Now we got addition. If I want to find the area of that, I got multiplication. Oh, that's easy, multiplication. I just have to multiply two numbers. And then, I mean, I teach middle school, so we use calculators as well, especially with my students who really lack the foundational skills of basic multiplication. The calculator is a godsend. I find it even with my own kids, if I'm giving them straight workbooks and straight testing out of testing after testing, oh, he hates it. And that can get scary. But if they build something, they'll have an understanding of it. And then that can translate, that skill will then translate over to the test and their understanding of it.
Thanks, sir. Hari, sir.
Yeah, ma'am.
Can I ask, sir?
Yes, yes, ma'am. Go ahead.
James, sir, namaste.
Namaste.
What are the simple math techniques to reach our little primary kids with joyful learning, sir?
Oh, I'm sorry. Can you repeat the question?
Answer. What are the simple math techniques to reach our little primary kids with joyful learning, sir?
Joyful learning. That's right. Yeah, that's kind of where I like to head with it. And you know, building games and building buildings and art projects are a really good way to get these concepts in, and then we can talk about them, have discussions about them, having discussions about you know, first understanding how to find the area of a rectangle. But we don't do it on pencils and paper. We do it by chopping up cardboard. So now you got their engagement. I'm cutting things out. Now I got the cardboard. Oh, it's 20 inches this way, 10 inches that way. How much cardboard is it? And then kind of understanding why it's square and tiling and it's square feet or square centimeters. Then you cut it in half and you got two triangles. Oh, I just needed to cut that rectangle in half. And then we have a conversation. How do I find the area of one of these triangles? Oh, it was a rectangle, but then we cut it in half. Then you can say, oh, how do you cut things in half with math? And then maybe someone else in the class will say, to divide by 2 means you cut in half. Oh, so maybe if we we measure the height and the base like we did for the rectangle, then we divide by 2, we got a triangle. So that's kind of a way to bring in that joyful learning and teach the concepts. And that discussion part is so important.
Thank you, sir.
Thank you. We call them math talks.
So any more questions, please?
Sir, can I? Hari sir.
Yes, sir. Parmagar.
Sir, this is Srinivas sir. Namaste. Good afternoon. Good morning to you, sir.
Namaste.
Sir, what are the methods followed in your country to teaching mathematics in a easy way?
We have a lot. I mean, the one of my favorite method is constructivism. And that's kind of the main pedagogy that we have, where we introduce a project. Then, for instance, with the cardboard box arcade, I will show them the Kane's arcade video, and then they see the kid playing the game with all the cardboard. They get really excited and they get real fun, and then they start brainstorming ideas. Then the next day, then the next day we ask kind of the questions of what would it take to find the how much cardboard we used, and then area. And then we take the cardboard up and we kind of break it down into the steps. And then at the end, they put it all together. And along the way that we're talking about it. Constructivism is a very popular one. Another one I really like is called CGI math, where you get a word problem, but you take away the numbers and then you give them 3 sets of numbers. Some easy ones, you know, 10s and 5s. And then some medium level ones, 30 and 72. And then some harder ones with more digits that are, you know, like 196 and 53. And then they solve the same problem 3 times with different sets of numbers. So then they're using the same formula that they kind of figured out and discussed. And then afterwards we have the math talk, and we learn how just because Raj solved it this way and someone else solved it that way, you don't need to do the same way to solve it. There's more than one way to do a math problem.
Thank you, sir. Thank you very much. Thank you very much. You mean playway method? Yes, sir?
Yeah.
Am I right? Sir, one more question, sir. How much time spent with your children in school time, sir? How much time spent with your school children?
I'm a middle school teacher, so I have an hour a day with them. When I was elementary school, I'll go a little nuts sometimes and I'll give them more time just because we're all having fun and they're all learning so much. But we can't always do that. But in elementary, I usually gave an hour and a half for math and an hour and a half for English. but right now in middle school, we get an hour a day for math.
Thank you, sir. I am very happy with interacting with you.
I'm very
Thank you,
happy
sir.
I can talk with you. The feeling goes both ways there, bud.
Thank you, sir. Thank you.
Thank you.
Ramesh garu, are you available, sir? So any more participants, please?
Sir, James, sir, it's very good afternoon and good morning, sir.
Good afternoon.
And in elementary school, so how do you teach the operations of addition, subtraction, multiplication, and division for elementary school as a part of our daily activities, daily life activities? How do you take an example of that?
You know, like, are you talking about algorithms, like carrying numbers and stuff like that?
Yeah.
I use Minecraft a lot to kind of show how the algorithm works, kind of stacking blocks 10 in the 10 places, 10, or money's a good one. 10 pennies make a dime. So you would, oh, there's a really good one you guys would love. It's called counting collections. Yeah, so what I'll do is, you know, I'll go to the dollar store and buy toothpicks, or we would use a box. How many Cheerios are in a box of Cheerios? And then I'd put them into groups. And then of course there's people going 1, 2, 3, 4. Wow, that's really hard. Oh, how about I count them into tens and put them in groups of tens? Some people will put them in groups of 15, and then they'll start realizing what a carryover is. Once they got the concept, boom, now I can teach the algorithm.
Okay, thank you.
So
Counting collections.
James, sorry to interrupt you. Here we have 1 minute time is left in this free Zoom version. So I request you and our participants to reconnect again because we can have a few more questions from our participants. So James, will you be available?
I'm always available for you, Harry.
Okay, participants. So I'm going to end this session right now because you have only a few seconds left. So we can start one more new session now.
All right. Namaste.